Hello viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're gonna talk about video lights. So let's dive right into it. Now first we have to understand light matters, and here in today's video we are talking about the science behind it. So you have to understand it. Nothing flat out in this world beats solar light quality. Not because we can't create something better than that. The problem is that our eyes evolved based on the spectrum of the sun. So basically everything that looks good to us in terms of light quality is directly proportional to sun. If we are teleported to another planet which has different kind of sun, let's say, rather than normal average yellow star to blue star, we're gonna be very sick there, because again it will feel weird to us. Light quality is very critical. Basically best light quality is solar light quality. However, given that said, that many studios, many production company and starting YouTubers, all they do is basically try to shoot as close to daytime as possible. Like that's the first advice you will receive if you are starting YouTuber, is like, hey, if you don't have money for video lights, shoot near a goddamn window. That's the best quality light output. Consequence is that you don't control the time. So, and many times, for example, let's say this assassination scene, you have to understand, yes, you want the car to be outdoor, but consequence of that is that adding CG elements on top of that becomes very difficult because of reflection, and if you're not controlling it, you can't just add into it. So many times even the scenes that you think are shot outdoors are shot indoors, simply because of the control element. And the more CG elements you need, the more people will be like, yeah, let's just shoot it inside, don't even think about it. And sometimes you just have to shoot at night, like Harry Potter. So you have to understand, artificial light is not an option, it's a must. And one critical aspect is, there are a very significant thing that you learn as you grow up. Is like, first thing you will learn, oh, raw file can allow me to post process, but you soon learn that you should not use a raw file as a crux, as a oh, I shoot wrong, then I try to correct it in post. That's never the intent. Same goes here, and this time it's much more critical. For example, if you have bad light, for example a light that itself is blue, no amount of post processing will ever correct this to this. Be very mindful of that. So if you mess up the light for whatever reason, for whatever miscalculation, it cannot be fixed in post processing. So this is one thing you have to understand, especially in nighttime scenes, especially when they have street lamps. Many times they will show the street lamp, but the lighting would be done separately, simply because street lamps are horrible. I will explain more in the further, but you get that point. You will always want to control light, and you want to spend money on quality, because if you don't get quality light, you will get a system that no amount of raw, no amount of RE, no amount of red camera can fix that. Be very mindful of that. Once you mess it up, you just basically ruined your project. And it has happened in the past where there's scenes had to be reshot simply because bad lighting was used. That's why that's how Hollywood learned in the quote unquote the hard way, that the hustle spend money on lighting. That's why when you type proper pro grade verified certified video lights, they are ludicrously expensive, and that's the primary reason behind it. It's there is a reason for that. It's not just oh, we are exploiting more money out of course, there are two aspects to it. First, the very low supply and demand, and then there is the fact that they are ludicrously more complex to build. Now, why light that is suitable for video quality is so complex to make? Well, types, because each light has its own quote unquote spectra, own signature. Now that signature simply creates an issue for us, because we are used to daylight, lovely smooth butter, no spikes, everything is awesome. Now of course you can zoom in and you may find spikes, but you get that point. For all intents and purposes, it's a smooth system. Now incandescent or halogen is the closest thing that we have that creates a smooth system. Now be mindful, it does create a boatload of infrared, so that's why you're getting a graph that goes like this. And you can if you basically have some halogen gas, you can enclose this and get a bit more up, so that will improve the efficiency, but it will also increase the cost. That's the best light output we have on this planet. That's okay, if you're getting bad color, either you have a bad lens or a bad system setup. Flat out, lighting cannot be at fault if you're using incandescent, because it has smooth spectrum output. There is no bumps, there is no spike lines, there is nothing. It's awesome. It's best color rendering, flat out, as close to natural system as we can get. The end. That's awesome. However, the worst player in this puppy is fluorescent or compact fluorescent, CFC. To give you a context how bad it is, it's if you build a there are many open source software that allows you to use your webcam as a light spectrum. Basically you can see these things. That's the way they calibrate it. It's just put a CFL there, it will have so many spikes. Based on the gap of the spike, it can calibrate based on your sensor. So that's the spiky part, and that's why the color rendition of this sort of things are horrible. Meaning it's it's bad. It's like your skin will look weird. Like many times people come in and it's like they look sickly and like they look ugly. It's like, yeah, light, if the light is this bad, it's really bad. And sodium lamp is even worse than that, because it at least has blue, red and green. Sodium will have simply one yellow here. That's it, nothing else. That's why if you try to ever photograph something in sodium lamp, yeah, good luck with that. It's really horrible. And CFL, that's why CFL never actually became something popular in movie industry, because of this bad color. Basically it can mess up, like you can have like 10-20 quality cinema lights, one bad CFL, it will mess up everything simply because of the spiky outputs. Then we go to LED. Now LEDs do not come in white. Physics does not allow basically non-monochromatic light to be created from LEDs. So people created a quote-unquote transformer stage, meaning huge high power blue LEDs. Okay, awesome. Then you have a step down transformer known as phosphor layer, which takes very high energy blue photons and step it down to red and green and yellow. Basically that creates a smooth system. So compared to incandescent, it still is spiky, but it's much better compared to CFL. And in modern development, there are people who are working on very expensive LEDs, which instead of using blue LEDs, they are using purple or ultraviolet LEDs, and they are using much different phosphor composition, and that's giving this lovely daylight output. Consequence, they're expensive, meaning your bank balance is gonna go poof. That's kind of expensive. And because of the prevalence of LED, most companies are investing in money to compensate this basically blue spike. There are some modern LEDs that bulb you can buy that will have red spike. Now that red spike is just to compensate, so overall color radiation would be really good. But be mindful, even this is like, this is the second best option. The best option is still at this point in time is incandescent, and that's why you will always find like a very high quality RE lights or Synex light, they will literally have 3 color LEDs rather than white LED. And that's the actual reason for that. If you have 3 independent LEDs, you can tune them. So rather than spike being random spike, you can fine tune where that spike is. So if you are properly controlling how the scene looks, you can be like, okay, the light is weak in this direction, I will change the color balance to make that feel proper. So that's why there are inherent limitation of the types. Basically no amount of voodoo work will ever make a CFL look good, and no amount of system will ever beat incandescent. Everything else is second best. Now of course, if you get close enough, if you get good enough, at that point it's good enough. At that point is like, yeah, human eye cannot see there, yet the digital codecs that we use, basically the color volume that we use, like what's the biggest delivery color volume? It's a BT2020, basically HDR format. Like this sort of TV uses that. Again, there are some bigger volume, but like that's enough. Like basically if you have good LED light output, quality ones, it's good enough. Like it's not gonna show, oh, like I have like horrible spikes. It's like, it's good enough. So we can use LED, and people do use LEDs. But if you see LEDs that are way too expensive, it could be because it's using basically purple or ultraviolet LEDs, or it could be that basically having 3 RGB system. That's the easiest way to create a quality LED, which gives you proper basically controlled spikes, so to say. It's like control chaos. These are the type varieties that we have to deal with, and it's at physics level. You cannot bypass this. Now, how do you test that? Now, this is the part that you have to understand. That's the biggest issue with this world, is that CRI. That's the first thing you hear about, CRI, color rendering index. It's a really low resolution test, meaning it's such a low resolution test that people figured out how to cheat the system. That's how bad it is. Like, because of the because it came very early on and it became so easy to cheat, every manufacturer started to use that. Yeah, our CRI is very good, and because one manufacturer is using the other, I also had to use it. Then it created a system where CRI is simply not dying. And what does that mean? That simply means CRI, higher the number the better. Basically closer to 100 GG. What is 100? Basically sunlight. So closer you get to 100, that's a better it is. Meaning anything that is 70, do not use it for any video or photo work. Anything that is above 80, good luck. Anything above 90, GG. 95, super awesome. However, 2 CRI lights, basically let's say you buy LED, that is like a true original, they are not scamming you or anything like that. A true quality LED from Philips. You buy something true quality LED from Cree, and both could have a CRI rating of 95.6. Let's just say that both are absolutely precise, 95.6. But here's the deal, you will use one of them, you will find your colors are different. You use another of them, color are different. It's like, how the heck that happened? Both have exact same CRI. That's why CRI is a very low resolution test. It's like very sloppy. It's like saying voltage. That does not mean anything. If it's an AC system, you have to specify the frequency, so you can calculate the proper RMS. If it's basically if you are talking about powering an appliance, you also have to provide the amps. So you have to provide amps, you have to provide frequency. then voltage makes any sense. Same happens here. CRI is just not precise enough. People figured out that CRI was limited, then they tried to create many more systems, extended CRI. All of them have failed, and all of them have same problems one way or the another. Like for example, CRI had like a very small color swatch that is started like all these colors should look good. Then people figured out like, these colors are too, too narrow. Human eyes can see millions of color and you're using 8 to 10 swatches. That's not good enough. So then they're like, okay, we're gonna use extended. But again, CRI is a standard. Once you made it, you can't change it. So then they created another standard like TM30, which is at this point in time is really good, but still has the same issue. It has 100 colors. Now you're like 100 color, awesome. It's still 100 millions of color versus 100. So my best like award for the awesome tool that is like mind-bogglingly awesome and removes observer, meaning when I'm talking about color swatches, who the heck is looking at that? Human eyes. And for other standards that were created that was dealing with the broadcast industry, they were like, how the heck camera sees it? But here's the, when you are creating something like that, you always create an issue of observer. Camera already had that issue because all broadcast camera back in the days were 3 CMOS system. Basically they had 3 sensor RGB. That was the easiest way to handle the processing, simply because rather than debaying the system, it was like RGB and compression can be done independently. That was super easy, and still that technology has been used for 8K broadcasting. But here's the, everything in between forgot to use that. So the color quality that will look good in 3 sensor will not look good in bare filter array. It's like observer created an issue. Same goes for our eyes. Our eyes are white. It's our eyes, but they are not absolute scientific instrument. So SSI was created, which is spectral similarity index, and that removes observer. That's like, take the observer, poof it. No sensor, nothing. It's physics, it's science, it's absolute. Now you will find an interesting part is similarity index. What does that mean? That simply means compare to what. Now at this point in time, we know that incandescent lamp is awesome. So incandescent lamp, that's the spectrum output. How close you are to that spectrum. That's it. Nothing else, nothing more. It's just like comparative. That's why the similarity is there. Sunlight. You will take that spectrum and you're like, how close are you to this? That's the easiest way to, absolute way to color match it. If you have something that, unless your equipment is properly working, you do not have a faulty equipment. If SSI is matching, let's say you have this LED and you have this LED, 2 LEDs both have exact same SSI within a tolerance of error, you will never have any color issues color matching these 2 LEDs. They will be exactly the same. That's the most amazing system I have ever found. However, right now it has the issue that no company actually wants to use this because this is super awesome. Every company is like, hey, CRI. Okay, again, other companies are like TM30. TM30 is much more difficult to cheat, and again, it's good, but again, SSI is much better. It's like, just take it and go. It's very expensive to find, meaning unless you buy a ludicrously high quality actual Hollywood grade lighting system, you will not find that SSRI index of that. And generally the best way to do that is buy equipment of this caliber, and they are expensive. Now it may look like a smartphone, but to give you a context, this will make iPhone look cheap. But there is a reason why people buy something like this. Again, there is a consequence. There is not enough demand for this, so there is not hundreds of companies making them, so price is ludicrously high. But once you have this caliber of tool, and let's say you have 2 of those tools and you are measuring equipment like this is LED light. I don't even need to check what is the light is, because that blue spike and that orange spike, I get it. Yeah, it's a blue LED with phosphor system. Really good one, because the blue spike is not very harsh. I'm pretty sure this is a very high caliber LED. And lux is also very good. So utilizing this sort of tool, you can damn sure you can check the quality of light, not just the intensity. Intensity is easy, but quality of light is very difficult to measure. This sort of tool is the only way to properly justify that. And to remove any bias, any hoo-ha into this, you use spectral similarity index. It removes any doubt. If SSI is looking good to incandescent or close enough, and you tested it, and if you are using another light in another studio and you're like, it's matching that, you do not have to worry about it. Like, if you're getting bad color, it may be the colorist messing up, or maybe you have a defective sensor. So that's the amazing part of it. That's why people spend boatload of money in this sort of equipment. Now let's come to real world. Now real world spending money is like, it's very difficult for a newbie or a starter or like, a small time system where it's like, that's a lot of money, but it's worthwhile. Flat out, it's worthwhile. Simply because many times, just to bypass this step, and low budget studio which has enough experience that they know that bad light, especially when company went from incandescent to CFL, they learned the hard way that CFL makes really ugly images, that many low budget studio, or like, if you are doing it on budget, they will still use incandescent and halogen. And you will notice that RE and all the proper pro companies did not jumped into LED very quickly. Like, LED came very early on, and you will think like these companies were selling lights that are like 4 kilowatt lights. You're like, dude, you should really use basically LEDs. They did not. They waited very long to, like, A, phosphor technology to develop, B, proper control circuitry to be developed, where if they are using RGB, they can properly get a good smooth gradient. All those things they needed, waited, developed, then they started to use LED system. And right now you can still find many scenarios where people are still using incandescent and halogen, because that is one of those things that you don't have to think about. It's like, and especially if you are shooting in winter, that's an added bonus. So this is one of those things, and broadcast industry is really critical to this, simply because there is almost mild to no post processing. And especially if you are talking multi-studio setup, where you have like studio A, studio B, studio C, you can't have like, hey, that person, like, many times the person walk between stages and they're like, wait a minute, that person was like, pink, it became orange here, what the hell happened? That's the same thing. Lighting could create such a issue in broadcast industry. They are very serious about that. Like, it has to be done properly. And multi-light setup requires you to have a proper high quality testing tool where you can match all the lights. If you don't do that, good luck, basically. Again, it was not an issue back in the incandescent day, but nowadays it is an issue. And especially if you're using LEDs, you have to make sure, because you could have a scenario where you have a backup LED which is not of the same brand or same manufacturers. People try that, but things happen, so you have to understand that. And cinema industry also does some very clever tricks. For example, many of the scenes which have like orange kind of lighting, you will think, hey, use sodium lighting. And heck, let's say street light shooting, you want to show that, you will use that sodium. No, what they do, they find a specific built basically halogen, which is very yellow. Now, like, why they use halogen rather than sodium? Well, sodium has a very spiky line, halogen has much better spectrum, so color output is far more pleasing compared to that looking that evil look. Again, that may be desirable, for you. You may want that psychopathic look, that I am gonna destroy things. You want that kind of look, go that route. You get that point. You need to know what each light can do. Heck, you can have CFL light if you really want to make people uncomfortable. You can have a, like, a bad person showing into like CFL lights. That's how bad it is. Like, you get that point. Like, you need to spend some serious amount of money into the real world, where people are have similar job titles as light producer. I'm not joking, that's the actual title. You get that point. Like, it is something that is serious. You have to understand, like, think of this, like, you hired a big actor, you have actress, you have scene, you have chemistry, everything is going awesome, and then in the video village, you're like, oh dude, the light is not right. What the hell you gonna do? You're hiring actors and actresses and all the sound engineering, all the setup is not super easy. You can just like poof it, unless you're Thanos. So you get that point. Like, this sort of investment in like properly understanding light, properly testing each of the lights, it gives you a confidence. Whereas, like, dude, lighting is not the issue. If you're having an issue, either the camera was faulty, lens could be corrupted, or lens coating sometimes could mess up due to humidity, due to salts. Things happen. It's like, okay, lighting is not the issue, and you always want that. You want, like, this is not an issue, this is not an issue. Then only you can narrow it down. You can't be like, maybe lighting is bad. So this is the real world implication of that, and that's why video lights are so ludicrously expensive, especially pro grade ones, and testing equipments are, well, makes iPhone look cheap. So this was my presentation on video lights. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. I would urge you to leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you are free, and as always, thanks for watching.